Welcome if you are joining us. We're going to wait a sec to see if other people are able to log on. I have a feeling we will have less people with us today because we are experiencing countywide some issues logging into Clever and logging into eCampus and stuff, so hopefully things will work. So I'm going to infinity screen again for a sec. Make sure the mic is working. Alright, so yeah, we will be, checking that things are working and stuff. Hopefully everything's going to go well today. Checking to see, I appear to be live. So welcome if you are joining us. Hopefully you are able to get on. I guess this is a good reason we're using YouTube and not something from accounting because, apparently with so many people trying to log on all at once, it's not working. But we will wait a sec to see if anyone else joins us. So if you are able to log into eCampus, you can use the chat. I can't log in to Clever on my second computer I have over here, so I'm going to have to be going kind of back and forth to the chat over here. So you can also, I did open it up, let me try logging again, but I did open it up that you can comment on the video. I'd already disabled the live chat. Oh wait, maybe it's working. I'd already disabled the live chat and I can't re-enable that, so I opened it up that you can comment on the YouTube video if you have a question as well. Yeah, no. Clever is still not working for me, but I'm already logged into eCampus on my primary computer. So, hopefully there's not too much of a delay, kind of, doing what we can. I got one computer over here, one computer over here. There's a lot going on. But we are working semi. I will get started. Let me know if you are here or something. If you can access the chat, post in the chat that you're here. I'd love to know that I'm not just talking to myself right now. But we're going to get started talking about some AP exam changes. So I'm sure you've heard this. There's no way to comment on the video. Oh look, we have people here. I said hi. So yeah, we're gonna have to be flipping back and forth between the chat. I think I opened it up to comments, so if there's not, sorry about that, but I'm new to this. That was weird. Oh, I guess that was the chat telling me there's people here. I might have to turn off the ding. That's a little annoying. But good morning. Glad to see you guys are alive and well. So I'm just going to go to AP. They have like a website set up for their changes, and we'll talk some about them. But the number one thing is that they're doing a lot of free learning resources. They have online courses. Ours is every day from... oh gosh, now I don't even remember what time. Ours is every day from 12 to 12:45. They're currently doing rotation. I believe they're about to start maybe with waves. So they're doing some topics right now. Start with rotation. Then they might do some waves in electricity, even though those won't be on your AP exam. But they're still important. So yeah, I recommend you watch those. But about this year's exams, there will be no face-to-face exams at school. If you want to take the AP exam, which I hope you do after all the hard work we've put in, the AP exam will be a 45-minute online free response exam. We don't know exactly what that means on April 3rd. Let's see, April 3rd is Friday. They're going to give us more information about that format of the free response exam. I'm not sure what exactly it'll be. The video is stopped right now. It might be your internet. Might be my internet. Who knows? But yeah, as I said, our AP exam changes are, it's going to be a 45-minute FRQ exam. You'll take it at home. We don't know how many FRQs, what types of FRQs, so we're just going to keep going with what we already know, and I'll update you on Friday with what else they tell us. And this is true for all of your AP classes. So there's going to be no waves and no electricity. So no waves, no electricity. I'm kind of sad about no waves because I feel like we were doing really well with waves, but I guess they wanted to make sure that teachers had time to finish the content. Apparently nationwide, a lot of people were still on rotation. So yeah, no waves, no electricity. We learned simple harmonic motion with the waves chapter. There will be simple harmonic motion. That is technically a separate unit than waves. So there will be simple harmonic motion, just no actual waves, transverse, longitudinal, sound, when we drew the waves, none of that, and then no electricity at all. So I said there'll be more info. April 3rd. So I still not able to log on my second computer, so I'm gonna have to just flip to the chat here. Thank you. I'm so glad there's people here and I'm not just talking to myself. It's so nice to feel like we're actually in class and not, still all by ourselves. I don't know. I thought I made it so you could comment on the video. Maybe not. Who knows? But yeah, if you have any other questions about AP exam changes, let me know. I could split screen the chat. I don't know. But yeah, if you have any other questions about the AP exam changes, let me know. Oh, I'm having my video freeze a little bit too, so I hope my internet is working fine. But yeah, we will get more info about how exactly you're going to be taking that online FRQ exam. That means right now your focus should be practicing some free response questions. So let's talk about our distance learning expectations. So our distance learning expectations this is kind of what we were already planning on doing, even if we were face-to-face in school. But now we're doing it at home. Is you have a review module in eCampus. I'll show you that in just a sec. But for the review module, your goal is to get 100 points on that review module. It's your choice how you want those 100 points broken up. You can do stuff where you watch videos, you can do stuff where you complete free response questions, you take practice quizzes, you do virtual labs. There's a lot of different types of activities, and it's your choice on how you earn those 100 points. Your goal should be to earn about 20 points per week. That gives us about a month that we're working on that review module, and that's, about right. So you should be earning like 20 to 25 points per week on that review module. My recommendation to you is that you work on it Tuesdays and Thursdays. That's what we were going to do in class if we were actually meeting together in class, is on Tuesdays and Thursdays we were going to be on the laptops working on the review module. So if we go into eCampus, welcome all the people that are here. Let me view it as if I was you. So some of you, by the way, were concerned about how you didn't have your notebooks or whatever. You do remember have the online textbook. You go to My Lab and Mastering to go to the online textbook. And then you do have all the old notes within each module. If you do have something you need from school and you want to get it, you have to email Mr. Blazewicz and schedule a time to come to the school. Less than 10 people are allowed on campus at any time right now. But we go all the way down to AP exam review. Here's the intro, read that. I want you to, to prove you're alive and well, so I have a little introduction activity right here. And then everything else, you choose how to earn points. If it doesn't say how many points it's worth, it's probably 5 or 10. A lot of the quizzes are 5 points, Quizlets are 5 points. The Nearpod will be 10 points. So things that don't have a points amount are probably 5 or 10. And if it doesn't have a way to submit it, you can always screenshot or something that you did, like the Quizlet, and show it to me. Message me, email me, whatever, that you did it. So yeah, here is the review module. A big points thing here is going to be the FRQs. You're going to have the 2016 and 2017 free response questions that you can do it and then score it and get 10 points for each question. You submit notes from the live lessons. You also have a few other things, watching a video and taking notes on it. Albert practice questions. If you go on Albert, there's a bunch of extra practice and AP review assignments that I created. Any of those you can do. I opened up all of the personal progress checks in AP Classroom. So if you go to AP Classroom, you're going to see like Unit 1 progress check, Unit 2 progress check. Go on and do those. Those are going to be 10 points each for doing those. And if you have suggestions for other point opportunities, oh, hi. If you have suggestions for other point opportunities, let me know, because I'm open to suggestions. There's a few units I feel like I don't have a whole lot on. I feel like I need to add some more forces stuff. I definitely need to add some more rotation stuff here. So I'm definitely still working on this. I don't know why this is only 3 points. I should probably add some questions. But yeah, that is kind of our expectation for the review module. I also kind of expect that you're attending 2 to 3 live lessons or watching them afterwards. If you can't come live, I totally understand, but you're doing about 2 to 3, and those can be from College Board. They're doing those Monday through Friday, so 5 days a week, or me coming to mine. And my recommendation is that you're doing this on Monday and Wednesday. And then on Friday, I have office hours for you, so you can kind of have Friday a little bit more relaxed, finish anything you need to finish for the week, and come to office hours if you can. Now, some of your other teachers might be using something called WebEx for office hours. And if you guys decide you like that better, we can switch to that. But I'm actually kind of glad that we didn't use that today, because the county's having problems and no one can log on. So, I don't know, we'll see what it's easier. Is YouTube easier? Is WebEx easier? We'll do whatever works. So my plan today was to do a brief review of kinematics, and then we're going to be going over a free response question together. Before we move on, does anyone have any questions on the AP exam changes or distance learning expectations? While you think, if you have questions, I apologize if you got 50,000 messages from me over the past few days. I feel like I emailed you separately, like 10 different things. I'm sorry. I'm trying to see if I can log on my other computer, but yeah, think about if you have any questions. Pause for a sec. Oh, it's working. Now I can access the chat on this computer. Hopefully your stuff is working too. But yeah, any questions before we start thinking about kinematics for a sec? Well, we get extra credit if we get more than 100 points like last semester. Most likely, are the live lessons going to be posted elsewhere? Yes. The live lessons, the recording of it will be posted. So if you go to eCampus, and you see, I don't actually have it up here, but I'm going to have, maybe as a separate module or something, like a list of all the videos. So I'm recording this right now, and if you can't watch live, you can access the recording. But yeah, probably extra credit for more than 100 points. I had a question, that was a good question yesterday, about like what your grades are going to be. So we're probably going to do like about 2 grades per week. And the 2 grades per week, I'm going to give you like a weekly grade, just that you've been doing what I expected. You've done your about 20 points per week, and that you attended some live lessons. Now we're probably, this is unofficial, but we're probably going to be out of school until at least April 30th. Right now we're only scheduled until April 15th, but we will probably be out of school till April 30th. So we are probably gonna have some graded quizzes. I don't have one scheduled yet. Maybe we can anticipate our first graded quiz next week. This week I feel like we're all kind of getting acclimated to this format, but we're probably gonna have some graded quizzes as well. So you're gonna get like a weekly grade for basically doing your 20 points on the review module and attending some stuff or watching it later. And then we're probably gonna next week have our first like graded quiz. What will happen during Wednesday office hours you suggest we join also? So in the office hours, it's going to be more open-ended. So kind of here, I picked a topic that we're going to talk about in just a sec. We're going to talk about kinematics. In office hours, you can ask me questions about any of the assignments you did. We can kind of your choice go over a topic, your choice, pick a free response question to go over. As I said, right now I have it that we're going to continue using YouTube, but if that's not working, or if you guys would rather use WebEx, which is more of like a video conferencing thing, we can use that for office hours, because those are going to be less formal. Like I'm not going to have as much specifically prepared. So on Wednesday and Friday, I have live office hours that you can attend as well. I don't require that you attend anything live, obviously, but if you can go back and watch through some of the things. But yeah, any other questions before we talk about kinematics? Alright, so I picked the free response question from 2019 we're going to go over here in just a minute. But first I wanted to recap kinematics. I really like the comparing rotational kinematics and linear kinematics video College Board did. So if you want to just recap how to solve kinematics problems, they do a good job of solving some rotational kinematics problems. I think that was the very first live video they did, so that'd be a great place to look. But let's just talk about Kinematics Basics. So remember that kinematics is the study of motion without regard to its cause. So what does that mean? That we are studying motion without regard to its cause, aka no forces. We're not particularly concerned about forces, though sometimes forces will help us study kinematics. I did make a more in-depth video. I have it on eCampus. It's called Kinematics in a Nutshell. I think it's like 15 minutes where I kind of do a basic recap of all of kinematics. But today we're going to just do like a brief, 10-minute review or so of kinematics. So our kinematics things that are important are distance and displacement, velocity, and acceleration. So when we're talking about kinematics, these are the main terms that we're talking about. How far something moved, how fast it's moving, how fast it sped up or slowed down. So distance or displacement, the symbol for that, hello Alex, is delta x. Velocity is a v. Well, you could have a v initial or a v final. Acceleration is an a. And I guess we'll go ahead and add in time, because time is t, and those are our 5 kinematics variables that we will be discussing. So we're going to take a look just way back to the beginning of the school year for a little bit at motion graphs. We'll switch colors. It's kind of, sorry if I'm like staring at the screen. So I'm writing on a tablet. I don't know if you can see it. I'm writing on a tablet, and it's kind of weird to be writing down here and looking at the screen over here. So writing a little bit slow. But motion graphs, we really have 3 different types of motion graphs. We have position time. We have velocity time. And we have acceleration time. So for our position time graphs, generally those don't go in the negative, though they could. It's going to be x versus t, velocity versus time. It's going to be v versus t, acceleration time. Yes, these are super straight lines here. A versus t. Oh, change color. There we go. Alright, so for position time graphs, you're just looking at how your object moves to or from the origin compared to where it started. So very simple. If we had something like this, well, let's go even simpler. If you had something like this, what would this object be doing if your position time graph was just a horizontal line? Well, this object would be standing still, because time is passing and our position is not changing. So what would that look like on our velocity graph? 0 velocity, because we are not moving. And then we'll look at our acceleration graph. 0 acceleration. Once again, we're not moving. All erase. Alright, so what about an object that was moving at a constant speed? What would that look like on a position time graph? Well, our position changes, but it changes at a constant rate. So that's going to look like this. Versus if you had a steeper line, that's going to be a faster constant speed. So what would that look like on our velocity graph? Well, our slope of this line changes. So when we want to read how our velocity compares from our position graph, we look at the slope. And this would be a horizontal line that is not at 0. And then what is the slope of this velocity graph? Well, the slope of a velocity graph tells us the acceleration. So once again, we'd be at 0. So that would be anything going at a constant speed. So let's take a look at something that is speeding up. So speeding up, we need something that has an increasing slope, because we read the slope as our velocity. So the slope of this line increases, which means our velocity is increasing. Now this is going to look something like this, because that slope is positive and it's getting bigger. So our velocity is positive and getting bigger. And then the slope of this tells us our acceleration, and it's going to have a constant acceleration. Generally, we're always going to have a constant acceleration. Maybe you could have something where the acceleration could jump to a different value if the slope of this line changed, but generally we're going to see horizontal lines on our acceleration graphs. because kind of to go past a changing acceleration, we would need calculus. So let's try slowing down. Slowing down. So we need something where our slope starts high and gets smaller. So this object is slowing down because our slope starts large and our slope gets shallower. So this object starts with velocity because it starts with a slope, and the slope approaches 0. And then this is a negative slope, so we're going to have a negative acceleration. You just found the chat, you're here. Welcome, welcome. So this would be 3 graphs for an object slowing down. Now all of my objects started at the origin. You could also have objects that do not start at the origin. So this would be speeding up towards the origin. So we start with 0 slope and our slope gets more and more negative. So this would be speeding up in the other direction. And then this is a negative slope. So we'd have this. So this object is speeding up and moving back towards whatever the origin point is. Versus if you had an object that was slowing down and started far away from the origin, you would need something, let's see. You could do this, where it was slowing down, going towards the origin, where here we start with a high speed, and our speed gets less and less. So we'd start with a very negative velocity, and our velocity would approach 0. And then this is a positive acceleration, so we'd have something like this. So those are kind of our main shapes of motion graphs. Do you have any questions on motion graphs, kind of in general, before we take a look at an example? And our example is going to include forces and how a force would affect this motion graph. But before we take a look at the free response question, do we have any questions on motion graphs or kinematics? Give you a sec if you are typing a question, because I know the video is probably ahead. Any questions? Just checking for email, making sure no one emailed me like, oh my god, I can't find the video. I am impressed, like half of you are here. That's a good amount of you guys to be able to come live, about half. I hope you've all had a relaxing, maybe not relaxing if you read news and stuff, but semi-relaxing 2 weeks. I've been home, not leaving the house, playing a lot of Animal Crossing, so hopefully maybe some of you guys got Animal Crossing if you have the Switch. I hope you did, because it's a super fun game. Alright. I don't see any questions. So we're going to do a free response question together. And our free response question is from last year's National 2019 FRQ 1. So if you can't see it well on screen, I know it's a little bit blurry. You can look it up. It's 2019 AP Physics 1 FRQs. So here we have, I'm going to zoom in a little bit. Whoop. Alright, here we have a kind of kinematics. Let me make my pen smaller since I zoomed in. Kinematics, forces, and then it's going to throw in a little bit of angular momentum at the end. So this is a good indication of the type of questions you'll see. I especially think that for this year, since you're probably only going to have 2 or 3 free response questions, that you will see questions that incorporate multiple topics. Remember, our topics are kinematics, forces, energy, momentum, rotation. Simple harmonic motion kind of goes in with rotation and forces. Technically a different topic, but you're going to see questions, I'm predicting, that are going to have multiple topics because they're trying to squeeze in everything they can into probably 2 or 3 questions this year. You have 45 minutes for your AP exam this year. But here we have 2 blocks. Blocks 1 and 2 are placed on a horizontal surface at points A and E respectively. The surface is frictionless except here. So here we have no friction, except for at C and D we have friction. So from A to B, we have a constant force applied to the block by this plunger. So here there is a force being applied. Then upon reaching B, it loses contact with the plunger and continues moving. So here there's going to be no force. Block 1 collides with block 2 at E. So here there's also no force. And then here there's no force. And they collide. Well, they're stuck together. So basically, block 1 is being pushed by this plunger from A to B. Then plunger goes away from B to C. From C to D, there's friction. And then from D all the way to F, there's no friction anymore. So we're sketching the speed of the center of mass of the 2-block system as a function of time all the way until our block gets to F. So let's kind of think about it before we draw it. I like to make notes on the side, especially if I'm doing like a real free response question, to have an idea before I actually draw. Because this is going to be worth 5 points, just as a thing for the free response question. This is a 7-point FRQ, and this graph is going to be worth 5 points. So let's try and dissect it a little bit before we draw. If there is a constant force, are you accelerating? And Newton's second law tells us that yes, if you have a force, your object is accelerating. Or our object specifically will be speeding up because that force is pushing it in the direction it's moving. So that force will be adding to its velocity, or it'll be accelerating. So I know from A to B, I expect acceleration. So this is A to B. From B to C, there's no more force. So if there are no forces acting on your block, now we can revert to Newton's first law and figure out that, well, if there's no forces, it will continue in motion. So from B to C, it will have a constant velocity. Scroll down a little bit. So from B to C, there will be a constant velocity. From C to D, there's friction. So that's going to be a force. See, it's moving this way. There's going to be a force in the opposite direction of its motion. So that means we're going to have like a negative force, or we're going to have a negative acceleration, or our object will slow down. Because the only force acting on it will be friction. Friction always opposes motion, so our object will be slowing down from C to D. And then we said from D to E to F, there's no force. Our boxes collide, but from D to F, we're going to have no force, which is going to mean constant velocity again. So how do we draw this? Well, let's think back to what we reviewed about motion graphs. Hello, welcome, Andrew. Let's see. So from A to B, we have a block that is accelerating. So how do we draw that it is accelerating? Well, it's a constant force, so that means we're going to have a constant acceleration. Now, this is a speed graph, or similar to a velocity graph, which means that if we drew this is going to mean constant speed. If we drew this means zero speed. So what kind of line are we looking for if we're looking for a constant acceleration? And that's going to be a line that slopes upwards. I'm going to do my best to draw a straight line. That looks straight. If your line does not look straight, I recommend you use like a ruler or something, or if I could cheat and use like the shapes. But I have a student that always writes like, this is supposed to be straight. If you're really bad at drawing a straight line, welcome, Jackson. So yeah, that is how we're going to show that our object is speeding up. Our speed increases at a constant rate. Then from B to C, we have a constant velocity because that force is no longer being applied. So how do we draw that? That does not look straight. Maybe I'll try again. Ooh, that's better. It's really hard to draw straight lines on my tablet. But there is our constant velocity, or constant speed from B to C. Then from C to D, we slow down. So what's that going to look like? It doesn't matter exactly how far you go down, maybe to here, maybe to here, but our object should slow down at a constant rate. So we should have a straight line to show a constant acceleration, and that acceleration is going to be negative. So maybe we go down, that doesn't look quite straight, I'll try again. Ooh. There we go. Ish. Kind of connect this right here. All right, so there's going to be our slowing down. So this is going to be speeding up, constant speed, slowing down. Then from D to F, there is no force. And I just want to recap here, I don't know if I mentioned this, that we're drawing the speed of the center of mass of the system. So basically we're drawing what's happening to the system. And at first, block 2 is just stationary. So block 2 does not contribute. But at E, block 2 does contribute. But when we're drawing the center of mass of the system, or the speed of that center of mass, we're basically only looking for external forces. So from E to F, they collide. But that force is considered internal to our system because our system is block 1 and block 2. So this is another kind of tricky way that AP exams are going to change the question a little bit. If we were drawing a graph for just block 1 or just block 2, we'd have a different answer. Maybe I'll draw that just to show you. But for block 1 has a force between 1 and 2. But if we're drawing the system, the 2-block system, the collision between them is not an external force. So what that means is we have a constant velocity here from D to E, and then we're also going to have a constant velocity all the way to F, because we are drawing the system and that collision is internal to the system. So if we were drawing this just for block 1, we would have a decrease in velocity here because block 1 slows down. If we were drawing for just block 2 would not move, and then it would move. So their total system velocity is the addition of their 2 velocities, so the system velocity is going to be up here. That was a really big missed part when this question was on the national exam last year. I want to say very few people kind of got that the collision between 1 and 2 is an internal force of a system. So this was 5 points. Basically, you got 1 point for drawing this this sloped line here with a positive slope. You got 1 point for drawing this 0 slope line. You got 1 point for drawing a negative sloped line from C to D. 1 point for drawing D to F, all horizontal. And then the 5th point is that your graph is continuous, except if you messed up and you put that the velocity would decrease at E, except at E, if you made that mistake, you could still get that point. So what that means is when you drew it, like maybe I'll draw a second one. You didn't have it go here and then it go here, and then it go here. So your graph basically all connected with each other. Like this is one continuous line all the way around. The only exception to that is if you drew that it jumped down here, you could still get that 5th point. So how we feel, we're quiet. How we feel about this motion graphs? Do you think you would have gotten this FRQ? This one's fairly generous. 5 points for drawing a motion graph, where there was only one kind of tricky part of it. What do you think? I'll give you a sec to decide. If you want to type something, let me know you're still watching. You feel pretty good about this? Thumbs up? Nice. So this question so far incorporated forces and kinematics. This question's part B. Oh, I love this. Good. I felt good about this. Very nice. You didn't forget everything you learned in the last 2 weeks. I'm impressed. But the question kind of takes a separate dive here in part B. We start getting into angular momentum here in part B. So this is a good example of how the national exam throws together 2 or 3 topics in one question. So now we can change the plunger back to its original position and we take the blocks away. We replace the blocks with a sphere. The sphere is pushed by the plunger from point A to B with a constant force. So here there's a force. Then it loses contact, so then there's no force. Then there's friction here in the highlighted area, and then there's no force again over here. So kind of a similar scenario. There's just no second block, but there's a force from A to B. There's no force from B to C. There's a force from C to D. There's no force from D to E. The sphere loses contact with the plunger at B, continues moving across the horizontal surface towards E. At which intervals, if any, does the sphere's angular momentum about its center of mass change? Check all that apply. So where does our angular momentum change? Well, let's take a look at what angular momentum is. There's 2 equations we learned to find angular momentum. I omega, or change in angular momentum, is torque time. So those are our 2 equations here. So where does our angular momentum change? Well, where do we have a net external torque? So we're going to have a net external torque from C to D. You just found the chat. Yay! Good job. So from C to D, we have a net external torque. Why? Well, remember, torque is force times radius. So where do we have a force being applied at a distance from the center of the object? That's going to be from C to D. So friction provides a net external torque and reduces our angular momentum, or our angular momentum changes. So this was 2 points. And basically that you referred to that you were looking for somewhere that had a net external torque, and that friction is the force that provides that torque. So one place here that some students did lose points was just saying that there's friction from C to D and it slows down. And you have to mention torque to get points. So that is 2019 question number 1. We're probably going to be going through all of the 2019 free response questions. We're going to take a look at a sample response, but just to show you, I never remember the name of the website, so I just Google AP Physics 1 exam. And if you look here, obviously this is not what our exam will be like this year, but you do have last year's free response questions with scoring guide, with sample responses, and a few previous years as well. If you click previous years, you have 15, 16, 17, 18, the released exam questions. So if you want to try to do any of these, we're probably going to be going through the next week or so, going through the rest of the 2019 questions. You can take a look at them on your own. Here is this question we're going over. Here's a forces one. Here's an energy one. Here is a kind of energy and electricity. And then here is a waves one. When we're doing practice free response questions, do you have a suggestion on where to get the equation sheet? So if you literally just Google AP Physics 1 equation sheet, I can post it in eCampus as well, but AP Physics 1 equation sheet, you're going to see it. Make sure it says AP Physics 1 equations effective 2015 at the top. Yeah, this is our same equation sheet. So I'm going to download this and upload it to eCampus real quick. But that's a great way to find it. Google. Google's your friend. Let me go to eCampus. Let me leave your view. And I'll just put it at the top of the module as well. Oh, eCampus might not be working. I'll do that later. But yeah, it'll be at eCampus. Hopefully my video doesn't stall out. Hopefully it's just, that's Infinity View. Oh wait, there we go. I know the school stuff is going kind of slow because of everybody logging on all at once. You can see all the weird things I have on my computer. Making things for Animal Crossing. What was it called? I don't remember what I called it. I'll do it later. I'll update that later. That'll just be the equation sheet to help you out if you don't have it. Yeah. So we're going to take a look at scoring this FRQ from a previous year student and how they did. So let's recap how the first part was scored. So the first part, you got 1 point kind of for having each part of the graph correct. And then the 5th point was that your graph was continuous, meaning that you didn't have any hard breaks or anything. Was it in the second line of files? I want to try again. You're better at reading than I am. Oh, there it is. Thank you, Andrew. I have too much random. My folders are really organized at work, but they're not very organized on my home computer. I got like Animal Crossing stuff mixed in with stuff for school mixed with other stuff. It's a mess. Okay, so you have AP Physics 1 equation table. I'll put it in the AP exam review in case you don't have it. You can always Google to find it as well. But we got 1 point for each part of the graph, and then 1 point for having it continuous. So let's grade someone's free response question. So this is a real previous student's question. I love that they did stuff like circled constant force. This is a great tool to use. Something like I did up here where I kind of annotated my drawing. Great way to help you know what you're doing before you officially draw. So let's see. A to B, our object should be accelerating. Is A to B accelerating? Yes. B to C, no more force. So B to C, we should have a constant velocity. Yes. C to D, there's friction and it should slow down. Does it slow down? Yes. D all the way to F should be one constant horizontal line. That's a no. But is our graph continuous all the way to F, except for maybe at E? If they mess that up, no double jeopardy on getting points off twice for that. So is our graph continuous? Yes. Basically, they don't have something like here, and then their speed jumps up here, and you have like gaps in your graph. So Ms. is going to earn 4 out of the 5 possible points. Now notice that there were no required values on this one. You didn't have to have any sort of values. So even though their stuff was different heights than mine, they still get the points. So this is 4 or 5 possible points. Doing pretty good so far. Now let's take a look at their part B. So where does the angular momentum change? Angular momentum is conserved. From A to B, the force of the plunger results in a change in momentum. From B to C, D, and E, there is no external force. From C to D, there's a rough surface, means there is frictional force, reducing angular momentum. And finally, from D to E, momentum is conserved. So I'm going to take a look at this first sentence here. Angular momentum is conserved in the absence of an external force. What is wrong with that statement? Well, angular momentum is conserved in the absence of an external torque. Regular linear momentum is conserved in the absence of an external force. Angular momentum is conserved in the absence of an external torque. And the biggest thing they did wrong here is nowhere do they mention torque. They have an equation here, force times time. Angular momentum, change in angular momentum should be torque times time, or torque is force times time. So I feel like they're mixing up force and torque, and because they had no mention of torque, this earned a 0 out of the 2 possible points. Because the points were that you mentioned that angular momentum changes when there is an external torque, and that friction provides that torque. So even though they mention friction, they don't mention torque. So this earned 0 out of the 2 possible points. So this FRQ got a total 4 out of 7. That's pretty good. We don't know really how it's going to be scored this year, but that's generally, if you're averaging a 3 or 4 on your FRQs, that's going to be enough for like a 3 or 4 on the national exam. So this one did pretty good. Alright, so let's see what we did. We talked about some AP exam changes. Those were our AP exam changes, that you will have a free response only FRQ. Only exam that you will take at home. There will be no waves and no electricity. There will be simple harmonic motion and everything else before that, and we will get more info on April 3rd on the exact format of this exam. I'm hoping they tell us the types of FRQs they'll give us, and how many there will be. My distance learning expectations of you is that you are earning about 20 points per week on the review module, and that you attend 2 or 3 live lessons or watch them later if you can't attend live. My suggestion is that you work on the review module Tuesday, Thursday, and then you do live lessons Monday, Wednesday. It's really up to you. That's just a suggestion if you need help with structure. We, this week, do not have any additional required quiz grades, but we probably will next week. College Board says the exams would be open notes. You are taking it from home. Oh, excuse me, my tummy's rumbling. I'm ready for lunch. But you will most likely be required to use something called the Lockdown browser. They have not officially said this, but from what they've told teachers, there is a browser extension called the Lockdown browser. You will be most likely required to use that for your AP exam. It basically prevents you from using the internet while you're taking your AP exam. You will be able to use anything that does not require the internet. So if you have a notebook, if you have your textbook, you will be able to use that. Now, my caution to you is that you only have 45 minutes. I'm assuming they're giving you 2 or 3 free response questions. We'll find that out on Friday, exactly how many questions. Do not intend on just being able to look stuff up and being able to answer a question. They are probably going to time it in such a way that it's going to be more difficult for you to cheat. So, yes, you can use notes. But as one of my professors in college always says, you are not a chicken. You do not hunt and peck for the answer. If you are able to flip to something really quick to jog your memory of motion graphs before you answer this FRQ question that we just did, you will be able to do that, but it's going to be really hard for you to look at the questions and have enough time to find exactly what you're looking for. I don't know. We'll see what they say on Friday, and I'll give you more info on Friday based on that. So, are there any other questions from what we did today? Kinematics, our expectations, because we're going to log off in just a minute. I'm so thankful that about half the class was able to join us live. That is a much better turnout than I expected. But as a reminder, as you're thinking of if you have any further questions, I will be live again on Wednesday and on Friday. It's going to be the same link. So I'm just going to show you my personal schedule. And then I have a little graphic. If you go to the link when I'm not live, it should show you the hours I'm going to be live. This is my personal live schedule. My suggestion to you is that you're working on the review module tomorrow and Thursday. It's not required that you do it certain days, which is a suggestion. I will be live again with office hours on Wednesday and Friday. Our office hours will be from 2 to 3 both days. If there's no questions, obviously for office hours, I want your questions. If you have anything that you worked on the review module and you were like, I don't understand the answer to this question, I had a question about a specific topic, come with any questions you have. You can post questions in the chat anytime between today and office hours, and I will answer them during office hours. If there's no questions, I will be talking about kinematics. And then Friday, same thing, your choice questions. If there's no questions, I'm going to be talking about forces. So I did email you. Yeah, we scratched that. Thanks Two, I believe one person completed the assignment I created for electricity before we found out that there would be no electricity on our national exam. So thank you if you did that. But I did email you the live schedule. If you click on the link that you just clicked on to access this video, it will show you a little graphic of the live schedule, and I'll post it again. I'll remind you and stuff. But basically, you should see this little graphic right here on when we are live. If you try to click on this link before I'm actually live. So yeah, if you can't access it or you don't know how to access it, please message me. I feel like the best way to make this system work is for us to be in communication with each other. Now, I've been messaging you over eCampus. Hopefully that is the best way to reach you. So I will continue messaging you over eCampus if I have information for you. So I will be live again with office hours, Wednesday and Friday. Office hours are a little less structured. As I said, some other teachers are using a video conferencing tool called WebEx. If you're familiar with Zoom, it's kind of similar. If that would be easier for office hours, let me know. If you think the YouTube was easy, we can continue doing that. It's kind of up to you. I'm open to whatever works for you. So before the next time I see you, I have 2 requests from you. Number 1, if you did not complete the Flipgrid introduction, please do that. That's just going to be a thing where you make your own little video letting me know that you are alive and well. I want to see all your faces and feel more like we are still in class. And then for 4th period only, I'm going to be sending you a link. All of you will be doing it through your 4th period class. So 3rd period won't have to do it for me, but you'll have to do it through your 4th period class. I'm going to send you a link to a Google survey from Mr. Blazewicz. I think it's just like a check-in to the school that you are able to access the internet and stuff. So for 4th period only, you'll get a link today for a Google survey to fill out. 3rd period, you will get it from your 4th period teacher. And if you don't get it from your 4th period teacher, let me know and I will send it to you. Can we count this live lesson as one of the ones for the week? Absolutely. This live lesson today will count for one of your ones for the week. So if you were here, that counts. So I'm just going to show you. Oh wait, this is searching my videos. I don't want to do that. I just want to show you. Let's look at what weird stuff I get recommended. Lots of Frozen stuff. Let's go to the advanced placement channel. This is where they are doing the live lessons through AP. Right now they're doing AP US History, AP Euro, AP Physics C. If you scroll down to Sciences, ours today will be, I believe this is the one for today. No, maybe this one. Is on Newton's second law for rotation. Andrew, I'm gonna email you or eCampus message you the link for the Google survey. That is required for everyone in the school, basically just to let the school know that you are like able to access school stuff this week. But this is the advanced placement official lessons. Their ones they've done so far are on rotation. I go through an experimental design FRQ. That one was really helpful. This one was on rotational kinematics, and it does a little overview of linear kinematics as well. The one today is on Newton's second law. The one for tomorrow is on connecting angular speed and linear speed. So this is a great place to get some extra help and info. Remember, I'm expecting that you attend 2 or 3 things a week, whether from me or from College Board. Well, will other students be able to see our Flipgrid? I believe so. I want us to feel more like we are still a class, even though we are not physically with each other. So yes, you can, I believe, have it set where other people can see your Flipgrid. Hopefully you've used Flipgrid before. I've never used it for our class before, but I've used it. It's really simple. It's basically like you're making like a little 30-second Snapchat video. And my request for the Flipgrid is just that you like say hi and tell us how you've been. Simple. So any final questions before I log off? I'm 5 minutes over my scheduled time. Final questions. Well, I would like for you to have some sort of proof, whether that means you took notes or that you could just jot down and tell me like what you learned that day. Proof, keeping track of your distance learning expectations, so basically keeping track of what you've done, is extremely preferred so that I can give you grades as necessary. So yes, I would like for you to keep some sort of track of what you've done. I do have, you can also earn module points. I do have College Board live lessons where you can upload some notes to get 10 points for your module if you're uploading notes that you took. I also want to share with you, this was a suggestion from Abby. It has been an assignment to create your own review, where you can make your own Quizlet, make your own little video, make your own PowerPoint, whatever, where you can earn some points basically for creating your own study tool. I'm not requiring right now that you submit that you watch the lessons, but you should be keeping track of that. I might surprise you and ask for proof. Alright, well, oh, I thought I saw people typing. Well, I will still be available in the chat whenever you need me. I'm going to log off our live video for the day. Thank you for watching. If you have further questions, feel free to ask in the chat and I will still be available in chat. Thanks for watching our first live lesson. I feel like it worked. I'm so happy that it worked. Bye.